Hello, this is Mr. Humbard here. For this video, I'm going to be going over the Chapter 5, Section 1 assignment. And with this assignment, to start, go over the fact that I need to convert this value, find the acceleration first. So, it's a bit of a longer problem. 242 kilometers per hour. I have to make that into meters over seconds. So I want the acceleration value, which is going to be change in velocity over time. So now we do 1,000 meters to convert this over 1 kilometer times 1 hour over 60 minutes times 1 minute over 60 seconds. And now I'm going to divide that by my time of 2.18 seconds. And this should give me my acceleration value. Which I can find real quick. So now that I have my acceleration value, I can use the fact that force equals mass times acceleration. And I can solve for acceleration. Or in this case, I want to solve for, looks like the mass of the jet. So I will do m equals F over A. Just dividing A both sides. Once I have that, I can plug in my values. 9.35 times 10 to the 5 over 30.83588,175. I have to keep all the decimals here because otherwise it might make a mistake. I should get, so I do that, 30,321.81818. And I want no decimals, so I'll round that 8282. There's my answer, 30,322. All right, so for number 2, this time it's quite a bit easier. We just have to find A, which is going to be change in velocity over change in time. So from 16 to 9.7, 9.7 minus 16 over 1.22, looks like it's our time, initial, final. And now we find what that A value is. So type in all the numbers if I want, and then I'm going to multiply that by my mass, because F equals ma. So times that value by 950, I should get 0.73. And it looks like I want no decimals here, so round that up and get that value, negative 4,097.06. That's going to be newtons. So for number 3, here, there's a 90 kilogram firefighter. It starts at rest and lands with this speed, this time. So the average force is going to be F equals ma, which is m times v final minus v initial over time, which I can plug in all the values and get 90, starts from rest, so 4.5 minus 0 over 2.5. That's going to be d times 4.5 divided by 2.5. I actually get 162 on the dot. It's going to be in newtons. So here for this problem, number 4, we have a truck pulling this trailer, but the truck and the trailer are part of the same system, so we have to add the masses together to get the what mass we need. So 1,812 plus 622 equals m, because the force is over this entire thing. The acceleration is over this entire thing as well. So now we know the mass, which is 1812 plus 622. We can find the acceleration as well. Then we just use F equals ma. Plug in those values, so I'm going to do 2434 times 1.16. I should get 2823.44. Looks like I want no decimals, so I get rid of those. There's my answer. Alright. So for number 5, all we're doing is just, if we want to use that triangle, we can, or just plugging in the values, covering up, say, the A, we get F over M, or we could just plug in our values for F equals ma, and we get 4.3 equals 1.7 A, and divide 1.7 both sides, or we could divide A both sides as well. So a lot of ways to do this. Divide A on both sides. So however you want to do this, you get 4.3 over 1.7 eventually. Now I get 2.5294 4, and I'll round that to 2 decimals. So there's a 2 there, and there's 9 here, so I round that, and I'll get 2.53. All right, last one. Same kind of problem, except this time around it's the other way around. So 30 newtons F equals M times A. So here I need to just solve for M. Equals 36 over 3.6. And that should give me about, oh, I said 36, didn't I? I meant 30. About 8.3 repeating, but I want 2 decimals, so it's just 8.3. So that's it.